Have you ever, ever sat back and wondered, really wondered, how we even started studying life, like in a systematic way?
Hmm, that's a fascinating question.
How did that all begin? Because you, dear listener, you sent us, well, your thoughts, alongside, some really intriguing excerpts from the Stanford Encyclopedia of Philosophy, all about Aristotle's take on biology.
Oh, that's fantastic.
And that got us thinking. We thought, let's really dive deep into how this, well, he's a giant, right? This foundational thinker, how he first approached studying nature. Like, what was his method? What was he even looking for?
Right.
And the
Yeah.
big question, why does his work still resonate with us, like even today?
Well, it's really, when we think about the history of, scientific thought, especially in biology, Aristotle's just, well, his impact is just monumental, I'd say. He wasn't just, out there casually observing butterflies. He was systematically laying the groundwork for an entire field of study.
Right, right.
It's really quite amazing. I mean, consider this. For almost 2,000 years, his work in zoology, it remained, well, largely unequaled. That's a very long time.
Yeah, that is huge. 2 millennia.
Richard Owen, he was a big name in 19th century anatomy. He famously said that zoological science sprang from his labors. And listen to this. We may almost say, like Minerva from the head of Jove, in a state of noble and splendid maturity.
Wow, that's quite an image.
Right. I mean, that really captures it, doesn't it? It's not like this gradual buildup of knowledge. It's like a complete system of thought about the animal world. Just boom, fully formed right out of the gate.
It's like, bam, there it is.
Yeah.
And that's what we're going to unpack right in this deep dive, especially for you, our philosophically inclined listener. We're going to unpack Aristotle's method, his core ideas about animals, and how all of his biological writings sit together. Like the structure of his work, that's really important. Because what we're really after, what we want to understand, are the underlying principles, the big ideas that fueled his, well, you could say his obsession with studying the natural world.
It was a lifelong pursuit. And in this deep dive, we'll trace that journey. We'll start with his life, how his intellect developed, how his experiences shaped him. And then we'll examine his philosophy of science, but not in a vacuum. We'll see how it specifically applies to his biological studies. That connection is crucial.
Right.
And then we'll take a look at how he structured his investigations, how he organized his inquiries into the animal kingdom. And we'll wrap up with a bit of a puzzle. There's something quite intriguing about his overall approach to, to biological knowledge, something that's worth pondering.
Okay, so puzzle at the end. Keep us in suspense.
Definitely something to think about.
But first, who was this guy? Who was Aristotle? What were the influences, the intellectual currents, that shaped his, well, let's face it, his revolutionary work?
Right, so let's set the stage. Aristotle was born in 384 BCE in Stagira, a town in northern Greece. His father, Nicomachus, was actually the physician to the king of Macedon. Makes you wonder, right, if this early exposure to the human body, to medicine, if that sparked something in young Aristotle, his later fascination with all things biological.
That's a good point.
It's certainly possible. Now, his mother, Phaestus, she also came from a prosperous family, so Aristotle had a good start in life. At the age of 17, he traveled to Athens to study at Plato's academy. And get this, he stayed there for 20 years until Plato died in 347 BCE.
20 years. That's a long time to be immersed in, well, in Plato's world and his thinking. I mean, he must have absorbed so much. But, and our source reminds us of this, Aristotle eventually went his own way philosophically. He developed this deep passion for studying nature, for direct observation, for getting his hands dirty, so to speak.
That's right. He was a hands-on kind of thinker. He wasn't content to just theorize from afar. He needed to see, touch, experience the natural world firsthand. This led him to Assos in Asia Minor, and then to the island of Lesbos, which is where he met and collaborated with another significant figure, Theophrastus.
Ah, Theophrastus. I've heard of him.
They're really considered the co-founders of biology as we know it. It's fascinating, really. Aristotle focused his attention on animals, while Theophrastus devoted himself to studying plants. What a dynamic duo.
A powerful intellectual partnership for sure.
Now, later in life, Aristotle took on the very important role of tutoring Alexander the Great when Alexander was a young prince. But by 335 BCE, he was back in Athens. And together with Theophrastus, they founded the Lyceum, which Aristotle led until Alexander's death in 323.
What a life. I mean, talk about being in the thick of things, both intellectually and politically.
It was a turbulent time for sure, but Aristotle managed to make a lasting impact, and his work continues to be studied and debated to this day.
And debated, yes, absolutely. It's important to remember, and our source points this out, the works we have today, they're not the original manuscripts written by Aristotle himself. What we have are copies of copies dating back to the 1st century BCE, and they've been translated, so many times. They went through Arabic and then into Latin and finally into the modern languages we read today.
Yes, that's something we as philosophers always have to keep in mind. We're not just reading Aristotle, we're reading interpretations of interpretations, filtered through centuries of scholarship and translation. It's like looking through a series of lenses, each one adding its own subtle distortions.
It's layers upon layers of interpretation. Fascinating, but also a little daunting.
For sure. It makes you appreciate the importance of textual criticism and the history of philosophy.
Hmm.
Now, the core biological works we usually refer to are History of Animals, often shortened to HA,
HA.
then Parts of Animals, PA, and Generation of Animals, GA. And then there's this collection of shorter essays known as Parva Naturalia.
Okay, got it. HA, PA, GA, and the Parva Naturalia.
And there's this ongoing debate about whether we should also include De Anima, on the soul, as part of his biological project.
Oh, interesting. On the soul, that sounds a bit more metaphysical.
It is, but there are definitely connections, clear thematic and conceptual links between De Anima and his biological writings, but that's a discussion for another time.
Maybe a future deep dive. But for now, we're sticking with the big three, HA, PA, and GA. And to really grasp, the essence of his biology, we need to understand it within the context of his overall philosophical system, especially his philosophy of science. And the source emphasizes the foundational importance of Book 1 of Parts of Animals for doing just that.
That's absolutely crucial. You see, Aristotle didn't just jump into studying animals without a clear intellectual framework. He had a very sophisticated understanding of what rigorous scientific inquiry should look like. In his works on logic and scientific method, the prior analytics and the posterior analytics, he lays out this ideal model of scientific knowledge. It's a hierarchical system of concepts and propositions, all grounded in the essential natures of things and in fundamental principles.
So it's not just random facts, it's a system, a structured way of understanding the world.
Precisely. And this system, he argues, should lead us to causal explanations, explanations that reveal why things are the way they are, why they behave the way they do. And these explanations should be based on universal truths that belong to the subject matter itself.
Okay, I think I'm following, but can you give me an example?
Sure. He uses a geometrical example to illustrate this point. You know the fact that the interior angles of any triangle always add up to 2 right angles?
Yeah, that's basic geometry.
Right. Well, for Aristotle, this property belongs to all triangles, simply because they are triangles. It doesn't matter if they're equilateral, isosceles, or scalene. It's a truth that's derived from the very essence of triangleness.
I see. It's inherent to being a triangle.
Exactly. And for Aristotle, true scientific knowledge explains why a property belongs to a subject in this fundamental way. It appeals to its intrinsic, essential nature.
So it's about getting to the heart of the matter, to the underlying reasons why things are the way they are.
Precisely. Now, transitioning from this ideal model of scientific understanding to the often messy process of actually doing science, inquiring into the world, Aristotle confronts a challenge. It was first articulated by Plato in the Meno. It's the question of how we can even begin to inquire into something if we don't already know what we're looking for.
Ah, yes, the paradox of inquiry. How can you search for something if you don't know what it is?
Exactly. It seems like a catch-22, doesn't it? But Aristotle has a brilliant solution. He argues that our sensory experience, while it doesn't constitute scientific knowledge in itself, acts as the crucial guide for our investigations.
So like a starting point, a way of getting our foot in the door, so to speak.
Precisely. It gives us an initial grasp of the phenomena, a preliminary understanding that we can then build upon through further investigation. And in doing so, we can move from mere sense perception to a more profound and systematic understanding of the world.
So sensory experience provides the raw data, the initial observations, and then reason comes in to organize and make sense of it all.
That's a great way to put it. And building on this, Aristotle outlines 4 primary objects of scientific inquiry. The first one is the fact, or hoti in Greek, which means that something is the case. The second is the reason why, or diati, which refers to the cause or the explanation for something. The third is if something is. or a-esting, which deals with the question of existence. And finally, there's what something is, or t-esting, which aims at uncovering the essence or definition of something.
Okay, four objects of inquiry. The reason why, if something is, and what something is, and how do these relate to each other? Are they independent, or is there a connection between them?
Aristotle sees them as interconnected and often sequential. So, establishing the fact that something is the case allows us to then ask for the reason why it is so, and confirming the existence of something naturally leads to the investigation of its essential nature.
So it's a process of discovery, a journey from observation to explanation, and ultimately to a deeper understanding of what things are and why they are the way they are.
Exactly. And the source highlights the significant role of the middle term in syllogistic reasoning. You remember syllogisms from our logic deep dives?
Vaguely. Remind me.
Okay, so a syllogism is a type of logical argument that consists of three parts: a major premise, a minor premise, and a conclusion.
Okay.
And the middle term is the term that appears in both premises, but not in the conclusion. It's the link, the bridge between the two premises.
Okay, I remember now. So how does this logical concept connect with causal explanation in Aristotle's philosophy of science?
Well, for Aristotle, the middle term in a valid syllogism, it's not just a logical link, it's also the key to understanding causal relationships. In the context of scientific understanding, the middle term identifies the cause that explains the connection between a subject and one of its attributes.
Okay, so it's not just about logic, it's about explaining why things happen.
Exactly. So, for example, if we know that thunder is the noise of fire being extinguished in the clouds, then the middle term would be fire being extinguished in the clouds.
Okay, I see.
That's what connects the subject, clouds, with the attribute, noise. And it also explains why clouds produce thunder. So for Aristotle, truly knowing the cause of something in this way is simultaneously grasping its essence.
So cause and essence are like two sides of the same coin.
Exactly. And he even uses a biological example from the posterior analytics to illustrate this point. It's the seasonal shedding of leaves in broadleaf trees, like fig trees and grapevines.
Okay, that's a bit more concrete. So how does he explain leaf loss?
Well, you could say that these trees lose their leaves because they're broadleafed, right? But for Aristotle, that's not a deep enough explanation. He argues that real scientific inquiry strives for what he calls coextensive predications. This means finding an attribute that applies to all members of a specific group and only to them, and then, of course, uncovering the causal reason for this connection.
So it's not just about finding a correlation, it's about finding the underlying cause.
Precisely. And in the case of leaf loss, Aristotle posits that the solidification of moisture at the juncture of the leaf stem, that becomes a more fundamental cause and thus a more integral part of the explanation and potentially even the definition of why broadleaf trees exhibit this phenomenon.
Okay, so the solidification of moisture is the key.
According to Aristotle, yes. Now, what's especially interesting for us philosophers of science is that this whole process presupposes that we can accurately identify these fundamental scientific kinds, these natural groupings. The analytics provides the logical framework for explanation, but it doesn't tell us how to carve nature at its joints, so to speak.
That's a good point. How do we know which categories are the right ones to start with?
Exactly. That's the million-dollar question. And that's precisely where Parts of Animals Book I comes in. It tackles this very challenge. It's
Yeah.
about establishing criteria for identifying these fundamental biological categories, the appropriate subjects for our scientific investigations into the living world.
So we see a progression here. The posterior analytics lays out the general theory of scientific inquiry.
Yes.
And then Parts of Animals tries to apply that framework to the messy reality of studying living things.
It's a crucial bridge between the abstract and the concrete, between the logical principles of scientific inquiry and the specific challenges of biological investigation.
All right, so before we dive into the specifics of Parts of Animals Book 1, the source raises some important caveats, some things we need to keep in mind when studying Aristotle's biology, especially from a philosophical perspective. First, it reminds us that the activity of actually studying animals, observing them, dissecting them, that kind of thing, is distinct from the written accounts that have survived. We only have the latter.
That's right. We don't have Aristotle's field notes, his detailed records of dissections, his sketches,
Right.
those day-to-day observations. What we have are these carefully structured, highly theoretical texts. They present the results of his investigations, but the nitty-gritty details of his methods, those remain largely hidden from us.
Like a peek behind the curtain is missing. We can only speculate about his actual process.
To some extent, yes. We can, of course, infer certain aspects of his methodology. It seems likely that he consulted with people who had practical knowledge of animals, hunters, fishermen, farmers, and he probably performed dissections himself. Maybe he even drew diagrams to aid his understanding. But we don't have direct access to that. It's all conjecture.
Right. And then there's the question of the purpose of these texts themselves. What was Aristotle's intention in writing them? They don't read like simple lecture notes. They seem much more carefully crafted and organized.
That's a good point. The way they cross-reference each other suggests a deliberate order of study, perhaps within the Lyceum. It's like a curriculum, you know? But what's interesting is that the history of animals, which you might think is the foundation, the descriptive groundwork, it doesn't actually reference the more explanatory treatises, like Parts of Animals or Generation of Animals.
This is odd.
It is, and it suggests that maybe HA served a different function, maybe as a reference work, a compendium of observations. It's like he was collecting all this data, all these facts about animals, and then leaving it to future investigations to explain it all.
So HA is the what, and PA and GA are the why.
Exactly. And finally, and this is crucial, the source reminds us that the version of Aristotle's works that we have today, it was probably compiled and edited centuries after his death. So what we're reading is the product of a long and complex history of transmission and interpretation.
So many hands have touched these texts over the centuries.
And each one has left its mark. It's a reminder that we're not dealing with a pristine, unmediated record of Aristotle's thought. We're dealing with layers upon layers of interpretation.
Just like an archaeological dig, unearthing fragments of the past and trying to piece them together.
A good analogy. And it makes you realize that interpreting Aristotle requires not just understanding his words, but also understanding the context in which they were written, the historical circumstances, the intellectual traditions, the whole shebang.
It's a humbling reminder that we're always standing on the shoulders of giants, but those shoulders are often shrouded in mist.
Indeed. So with these methodological caveats firmly in place, let's finally turn our attention to the specifics of the philosophy of biology articulated in Parts of Animals, Book 1.
Okay, let's dive in.
Our source indicates that the primary purpose of this book is to establish a set of standards for judging natural investigations. It's like Aristotle is setting the ground rules, the guidelines for doing good science, especially when it comes to studying living things.
Guidelines for good science, I like that.
And there's a clear and explicit connection between this book and the principles laid out in the Posterior Analytics, his treatise on scientific method. The first piece of evidence for this connection is that Aristotle himself, in passages that introduce his biological inquiries, he seems to directly allude back to the theory of scientific knowledge that he articulated in the Analytics.
So he's explicitly linking his biological work to his broader philosophy of science.
Absolutely. The passage in History of Animals I-6 is a prime example of this. It's where he outlines the necessary steps for studying animals, and he emphasizes the need to first grasp the distinguishing characteristics and attributes of all animal kinds. And then, and only then, do we move on to the discovery of their underlying causes.
Okay, so first we observe, we collect data, we describe.
Exactly. We get the lay of the land, so to speak, and then we start asking why things are the way they are.
Yep.
And he explicitly says that it's natural to investigate in this sequential manner, starting with careful observation and description.
It's like building a house. First, you lay the foundation, then you build the walls, and finally you put on the roof.
That's a good analogy.
Yeah.
And he even uses terminology that echoes the posterior analytics. He talks about that about which the scientific demonstration should be concerned and those things from which it should proceed. This really points to a deliberate and overarching structure for his entire biological project. It's a project that methodically progresses from initial factual inquiry to causal explanation.
So History of Animals is like the foundation. It establishes the fact, the hooky. It meticulously identifies and describes all these differences and attributes among animals.
Right.
And it might even use the method of logical division to do this.
Which is something we've discussed in previous deep dives on logic.
Exactly. And then Parts of Animals and Generation of Animals, they come in to provide the explanation, the deity, the reason why things are the way they are. They aim to uncover the underlying causes, the essential nature of these observed phenomena.
Precisely. And the source raises an interesting point about an ongoing scholarly debate. It's about whether the primary goal of HA was actually to define animal kinds or whether that categorization was more of a secondary outcome.
So the debate is about whether he was primarily interested in classification, in creating these neat categories of animals, or whether that was just a means to an end, the end being causal explanation.
That's the crux of the debate. Were his initial efforts focused on taxonomy, on creating a system of classification, or was that system just a tool, a scaffold, for his ultimate goal of understanding the underlying causes, the essential natures of living things?
It's like, was he a stamp collector or was he a biologist? Was he more interested in organizing and labeling, or was he trying to figure out how life works?
That's a very good way to put it. Now, regardless of the precise priority, there are numerous statements within the explanatory treatises, PA and GA, that reinforce this idea of a preceding stage of factual inquiry. They often refer back to something like HA as the source for that foundational descriptive information.
So even if his primary goal was explanation, he still recognized the need for a solid descriptive foundation. You can't explain what you haven't first observed and described.
Exactly. And we see this even more explicitly in passages from On Animal Motion and Parts of Animals, the second one. These passages explicitly state that the hoti, that it is so, is already clear from their prior inquiries into nature. They say that their current task is to investigate the dioti, the why, the underlying cause or reason.
So they're acknowledging that they're building upon a foundation of already established facts. They've done their homework, so to speak.
Precisely. And this really reinforces the idea that Aristotle consciously structured his entire biological project to align with the principles of his broader philosophy of scientific inquiry. It's not just a coincidence, it's a deliberate methodological choice.
It's all part of a bigger plan.
Exactly. And the source presents a second line of evidence connecting PAI to the analytics. It argues that the specific topics that Aristotle addresses in this book, they can be seen as detailed specifications, adaptations of the central themes of the posterior analytics, specifically tailored to the unique challenges of studying living organisms.
Okay, so he's taking these general principles of scientific inquiry and applying them to the specific case of biology.
Precisely. And what are some of those unique challenges? Well, for Aristotle, living things are complex unities of matter and form. They arise through these intricate developmental processes that are guided by purpose, by a final cause, a that for the sake of which.
Teleology, he's famous for that.
Right. For Aristotle, things in nature don't just happen randomly. They happen for a reason. They're directed towards an end.
Everything has a purpose.
In a sense, yes. And their ends, their purposes, are causally and definitionally prior to their material components. This means that to understand a living thing, you can't just look at its parts. You have to understand its function, its purpose, its place in the natural order.
Okay, so form and function are intertwined. You can't have one without the other.
Exactly. And Aristotle also recognizes a distinct kind of necessity at play in biological systems. He calls it conditional necessity. This means that things are necessary given the organism's function, given its purpose.
So it's not absolute necessity, it's necessity within a specific context.
Precisely. A lung, for example, is necessary for an animal that breathes air. It's not necessary in some absolute sense, but it's necessary given the animal's way of life.
Okay, I see.
And finally, Aristotle advocates for a specific and nuanced method of division, multi-differentiate division, as the most appropriate way to classify living things.
So not just any old division will do.
No, it has to be done carefully, systematically, taking into account multiple differentiating characteristics. These are all crucial aspects of biological inquiry that the more general epistemological standards presented in the posterior analytics don't fully address on their own.
So PAI is filling in the gaps, so to speak. It's showing how these general principles need to be adapted and applied to the specific case of living things.
Precisely. And it starts by tackling the fundamental question of how to correctly identify the objects of scientific investigation in biology. What should we focus on? Should we start with familiar, concrete groupings like humans, horses, birds?
Those are the obvious choices.
They are, but Aristotle observes that focusing solely on well-known concrete kinds might lead to a lot of redundancy. We'd end up describing the same phenomenon, like leaf loss, over and over again for different types of trees. He suggests that a more fruitful approach might be to start with broader attributes that are shared across various kinds.
So instead of looking at individual trees, we look at the phenomenon of leaf loss in general.
Exactly. And then we explore the specific forms that this phenomenon takes in different species. But he also acknowledges that certain seemingly common attributes, like locomotion, might not manifest in a uniform way across all animal groups.
So some animals walk, some swim, some fly.
Right. And this brings us back to the importance of finding coextensive predications, those fundamental attributes that truly define natural groupings. It's a constant theme in Aristotle's biology.
And then he gets into his discussion of logical division in PAI 2.3. And he's not a fan of simple dichotomy. dividing a group into two mutually exclusive categories, like winged versus wingless. He thinks that's too simplistic.
It is, and it often leads to artificial groupings that don't reflect the real underlying nature of things.
And he also criticizes division based on non-essential characteristics, like dividing winged animals into tame and wild.
That's just arbitrary. It doesn't tell us anything about the essential nature of these animals. Instead, he advocates for a more nuanced approach. He says we should divide broader differentiae, the distinguishing characteristics, by their more determinate forms.
So instead of just winged, we look at the different types of wings.
Precisely. And we do this simultaneously across multiple correlated differentiae. We consider several distinguishing features at once, not just one in isolation. And this leads him to recognize the naturalness of certain groupings, like birds and fish. These are groupings that are recognized by everyone, not just by experts.
They're common sense categories.
Exactly. And he argues that they're valid starting points precisely because they're based on a multitude of correlated differences, not just a single, potentially superficial dichotomy.
It's like if it walks like a duck and quacks like a duck, it's probably a duck. That's a good way to put it.
And then he introduces these concepts of more and less, and analogy as crucial tools for understanding and defining these natural kinds. He argues that within a given kind, like birds, differences often manifest as variations in degree. Some birds have longer feathers, others have shorter feathers, but differences between distinct kinds, those are often best understood through analogy.
So a bird's wing and a bat's wing are analogous structures. They serve a similar function, even though they're built differently.
Exactly. And this recognition of both graded variation within established kinds and analogous structures across different kinds is absolutely fundamental to Aristotle's biological thinking.
It's a key insight.
And then we come to PAI-5, which is a kind of culmination of this whole methodological discussion. It famously begins with that beautiful and eloquent encomium to the study of all animals, even those that might seem insignificant or disgusting to some.
He's saying, don't be a snob. All creatures, great and small, are worthy of our attention.
Exactly. He argues that while studying eternal and unchanging beings might hold a certain intellectual allure, we can actually achieve a deeper and more complete understanding of perishable living things precisely because we have greater access to them.
They're right here in front of us.
And they share more of our own nature. He even quotes Heraclitus to counter this potential disgust at studying, lower animals. He reminds us that there are gods here too, implying that there's something inherently natural and good in every creature.
So don't turn your nose up at the slug. There's something divine in it too.
That's the spirit. And the analogy he uses, comparing studying animal parts to studying the blueprint of a house, that's particularly insightful. It highlights his focus on teleology, on purpose, on understanding the overall organization and the intended function of the structure, not just the raw materials.
So it's not just about anatomy, it's about physiology. It's about understanding how the parts work together to achieve a specific function.
Precisely. And he goes on to recommend that we should approach animal activities in the same way we approach their parts. We should see the organism as a whole, as a unified and complex system of interconnected activities and structures.
It's a holistic view of the organism.
Exactly. So PAI lays out this crucial philosophical framework for investigating the living world. It tells us how to adapt and apply the general principles of Aristotelian science to the specific and often perplexing challenges of biology. It emphasizes teleology, biological form, and this multifaceted approach to classification. And now the big question, the philosophical question, is whether Aristotle's actual biological research, as seen in his other works, actually follows this program.
Does he practice what he preaches?
That's the question. So let's turn our attention to Aristotle's biological practice, starting with his massive history of animals and its role as a Hoti investigation, a foundational inquiry aimed at establishing the facts about the animal kingdom.
Okay, back to HA.
As we discussed, Aristotle presents HA as this necessary preliminary stage. It's all about gathering and systematically organizing a vast amount of information about the diverse characteristics of animals before even trying to explain those differences.
Data collection.
Exactly. He's laying the groundwork. And as the source correctly points out, the work consistently employs this method of multi-differentiate division. It's structured around 4 main categories of differences. Their parts, both uniform and non-uniform, their activities or ways of life, their characteristic behaviors, what he calls their characters, and then further subdivisions within each of these broad categories.
So it's a highly organized system of classification.
It is, and what's particularly interesting is that groupings of animals become more central when he's discussing the differences among uniform parts, things like tissues. These groupings are often identified by noting stable correlations among multiple differentiae. So for instance, birds consistently possess wings, feathers, beaks, and they're typically bipedal.
So he's identifying those key features that cluster together.
Exactly. And if a particular group doesn't have a common name, he'll often define it by its key correlated differences. So he might talk about four-legged live bearers, for example.
So he's creating categories based on shared characteristics.
Precisely. And this practice demonstrates both the power and the limitations of this method of division. It's great for identifying and organizing a huge amount of data, but it doesn't necessarily get at the underlying causal principles. It doesn't define those theoretically significant biological kinds in a robust sense. For that, as the source notes, Aristotle turns to PAI4 and HAI6.
So division alone is not enough.
It's a tool, but it's not the whole story. Division can help us classify, but it doesn't tell us why things are the way they are. It doesn't distinguish between those features that are causally fundamental and those that are just incidental.
And that's a crucial distinction for Aristotle, isn't it?
It is. He wants to know the essence of things, not just their accidental properties. And to get at that essence, he needs to go beyond mere classification. He needs to delve into causal explanation. And the source emphasizes that this distinction between description and explanation is something that Aristotle himself recognizes and applies in his biological practice. We can see it most clearly when we compare the descriptive accounts in HA with the explanatory analyses found in PA or GA.
So it's a difference in focus. HA is about describing what is observed. PA and GA are about explaining why it is so.
Exactly. And to illustrate this difference, the source directs our attention to Aristotle's discussion of respiratory organs in blooded animals. In HA, he uses this pattern hesera.panta, which means as many as on all. It's like he's trying to identify those universal correlations, those features that are always found together.